Hi, thank you for joining the webinar today. We'll be covering Find That Element, Practical Tips for UI Element Locators. My name is Jason Epstein. I'm one of the product managers for Ranorex. With me today will be Timothy McDaniel. He is with one of our sales engineers. And we'll also be joined by another engineer, Jacob Brennicke, who will be answering your questions throughout today's webinar in the Q&A panel. So a few housekeeping items before we begin. Throughout the webinar, we will be answering questions in the Q&A panel. It's usually located in the upper right corner of the GoToWebinar window. And this webinar is being recorded so that you can watch it again later or share it with others on your team who maybe weren't able to make it today. Please consider limiting your questions to just what our topic is about today. If you have other questions that are off topic, please feel free to email our support or get in touch with your sales engineer. So over our little agenda today, we're going to do an overview of the UI element locator strategies. We're going to cover some tips to choose the right locator for a given use case. We'll also do a deep dive into the RanorexXPath syntax, and we'll also be troubleshooting some locators. If we have any additional time at the end, we might do some Q&A from the questions that we've received in the chat. So now at this point, I'll turn it over to Timothy.
Thanks for that intro, Jason. Let's start with an overview of locator strategies. Now, when you're automating a user interface test, one of the things that you have to do is find the elements in that user interface. A typical user interface is organized into a series of containers, nested one inside another. And to locate a given object, an automated test uses attributes such as the object ID, the class, the name, and the path to locate it within its container. So some locators are inherently more stable than others. Now, in the coordinate strategy, you locate a UI object based on the XY coordinates, the grid coordinates, plus a length value. And this strategy is easy to use, but for this strategy to work, the object must always be at the same spot on the screen. Changes in the UI layout can break the coordinate-based test automation. Sometimes when dealing with image-based automation, then it's necessary to use coordinates. For example, if you don't have a tree structure, you'll need to be sure that if you're testing on different machines, that they're using the same resolution so that the object is still the same. And then we have IDs, and every object has an ID. And the benefit of using an ID strategy is that it's going to be more explicit than other locator types, but it's also less flexible. You won't use the ID when the developers on your team have included permanent, unique object IDs for the purpose of test automation. Now, a major drawback is that many applications use dynamic IDs, and that change every time a UI element is loaded. And this can make ID-based strategies unworkable. Now, we're going to look at an example of this later in this presentation. And then we have names. The name locator strategy. This strategy involves finding a UI element by matching its name. For example, in this image, the name of the button is simply button. And this is a simple strategy that does not rely on the location of the element on the page. However, it does rely on the name of the object not changing. And if multiple elements have the same name, only the first one is returned. And then we have the XPath. And the XPath, that's the language used for locating nodes in XML or XHTML documents. And you can locate elements by relationship, such as child elements of the targeted parent elements. And XPath offers many more capabilities in locating elements by ID or name, and it can be more resistant to changes in the UI, which makes your tests more stable. There's also the link text, and link text, this strategy relies on finding a web element by the text of a hyperlink. So a pro is that it's an easy method, but if multiple items have the same link text, then only the first match is used. Changing the link text, if you change the link text, it's going to require that you update the test automation. just by going in, and you can go into the test in Ranorex and just edit that. So for CSS selectors, for web applications, a popular strategy is to use CSS selectors for locating the elements. And in CSS, a selector binds the style properties to the elements in an HTML document. And the pro of this, of using CSS selectors, is that they can be much faster than XPath and can also locate complicated objects. So a few troubleshooting tips. You want to be unique, and that is whatever locator strategy that you choose, make sure you're using a unique value. For example, if you have duplicate UI identifiers or elements in the same XPath, your test will fail. You want to get focus. Some elements, such as a drop-down menu, pop-up windows, and combo boxes, may become visible only after a mouse click and then disappear when the application loses focus. To handle this, make sure your automated test includes the steps that a user would normally perform to bring focus to the desired UI element. And finally, wait for it. To make sure elements are in focus, it may also be necessary to include a wait time in your automated test, and then delay the execution until the desired element becomes available or visible. And of course, my favorite troubleshooting tip is to use Ranorex Studio to make UI element locating much easier and more reliable. Now, Ranorex uses a proprietary strategy that we call the RanorexPath, which is based on XPath, but much more powerful. And so let's take a look at how the RanorexPath works. To start, I want to begin by explaining a few concepts of UI elements, as this will help you better understand what we are talking about when it comes to UI elements on the screen. So for example, we have a radio button here with the gender selection of female or male gender, and this is the UI element that's within the application under test. And every UI element in the application test has its so-called inner representation within Ranorex Studio, and the inner representation can be seen within the repository. And every UI element there consists of a so-called logical name, and it also consists of a RanorexPath specification. So Ranorex identifies the type of UI element on a best guess method, and then it maps it to a set of specific rows. Now Ranorex builds a tree-like structure, as you can see here on the screen. The path begins with the RX mainframe application, then the tab of the application, and then the text username element where the name would be entered. So now let me show you this in RanoreXPy. Now RanoreXPy is our tool of choice for today's webinar. RanoreXPy is responsible for identifying UI elements, tracking them, creating the RanorexPath. So what I'm going to do here is we have this open, and I also have the RX demo application open, and we are going to start tracking. So now we're going to track on the application, the Ranorex Studio demo application, and we're going to come down here to this field, and once we click on it, we can go to the path editor, and we can see how it basically went and found the different components. And you see it's all checking out here and showing everything the different levels that it went through, the nested levels that it went to starting with the form and then going down to the tab page list, and then finding the introduction tab, and then finding where it says the text username. So this is how Ranorex does these nested results, and you can see here when you click on here the different levels that as we go up you have the different components of the application as shown here in this image. But let's briefly discuss how Ranorex accomplishes this. Ranorex achieves this through a sophisticated approach, and I'd like to take a few moments to explain. So in this example, we have an application under test, and we have a designated radio button called female. Now, Ranorex initially, it tries to map to a technology-independent row. If nothing is found, then there is an unknown row. But in this instance, Ranorex identifies this UI element as a radio button. So, and then we distinguish between row-specific characteristics and technology-specific capabilities. Sorry, and with row-specific characteristics, you have general, layout characteristics, dynamic characteristics, and role attributes. And then this feeds into here, showing these different attributes. Enabled equals true, for example. Visible equals false. Or your control text here showing female. Also, in addition, with the technology-specific capabilities, you have your CEF plugin, or mobile plugin, Office plugin, or WPL forms, things of that nature. And if you notice here, there's 15 plus categories, 167 plus capabilities. These in turn also feed into the attributes, and you have over 643 plus attributes that are built are generated from with Ranorex for creating or finding the most proper RX path. So now that we've discussed concepts of the UI elements, we're going to talk about the so-called blueprint of the Ranorex path and its architecture. Here you see that it begins with an axis. The axis is usually one of these forward slashes, and then there is the node. In this instance, it's showing a row, the button row, and then you have some optional predicates that further describe the button. For example, here you have an attribute of control name, and you have a value of RX button exit. So to show you how this looks, we're going to come over here and track, and we will track that exit button as we saw in that slide. And when you look up here, you can see as outlined previously, you have the button, control name, and then here equals RX button exit. And we can do that pretty much for any of the different items if we wanted to see what that would look like. Right here we have the button, and the control name equals button submit user name. Now when it comes to a complete RanorexPath construction, you don't have one element, you have many elements, and the elements always start with a so-called root element at the beginning and a node element at the end, and in between you always have path elements defining the path from the root to the node. So for example, looking back at this particular submit button that we just did, if we go back to the beginning of the Ranorex path, you can see that initially it's showing you the form of the RX mainframe application, and then it's going to the tab page list and the tab page of the RX tab introduction. And if we go to the end, then it gets down to the button control name. So it's quite complex here. If we go through here and we look at the path editor, we can see from here the form, the tab page list, the tab page, and then the button submit user name. And also here we can say, you see here you have the submit button. If we go up, we can then see that it's going up to the introduction, and then it's going to the control tabs, and all the way up to the form itself. Now, Ranorex does this by a special type of strategy where it usually tries to be as detailed as possible. So Ranorex has a tracking strategy, and the tracking strategy always deals with robustness and the execution speed. For example, if a Ranorex path is very detailed, then it's not very robust against changes in the graphical user interface, but it has a very high execution speed because Ranorex identifies each UI element very uniquely. Now, on the other hand, if the Ranorex path is very flexible, then it becomes very robust against changes in the graphical user interface. So Ranorex is able to identify UI elements even if they change in position within the graphical user interface. But if the path is flexible, the execution speed draws down whenever the flexibility is increased, because Ranorex always needs to search again and again for the element to find it. And now I will show you an example of this. So let's go over to this Ranorex Studio demo application, and here we have various tabs, and this last tab is object identification. So we're going to use this, and this particular tab shows a lot of buttons we have, and these buttons have different levels of depth. You've got this pretty much right here. You've got your tree-like UI element structure here, and it's showing button 1, but then we can, and button 2, and we can delve here into these here under panel 1 and panel 2. You've got another level, and the same goes with, then again, when we go to panel 11, you've got button 1, button 2, and you can see below the tree structure, the element structure is going deeper on this. So let's go back in here to SPY, and we're going to track. And this time we're just going to track on button 1 from the top level here, and we can see quickly here the RX path that it was generated, and it shows that, it shows the form of the mainframe, and then the path goes down to the tab control, and then the tab object, and then we come down here to the control name for button number 1. And we see too that this took about 645 milliseconds for it to identify this particular path. Let's go to the path editor here, and we're going to refresh this so there you go. So it found the path, and you can see the structure of it going down and finding that particular nested element of button 1. So what I want to show you now is here under the settings, and under the advanced tab of the settings, we have something called the RanorexXPath settings as far as the speed versus the robustness. This is sometimes referred to as the quantal threshold. And what we're looking here is I've got mine set all the way, for speed. And on the other hand, you could change this all the way to robustness. And that's what I'm going to do here, just so that we can see what kind of effect that this has on the Ranorex XPath. So let's go ahead and hit apply, OK. Okay, so what we're going to do now is go ahead and track. This time we will track on the button number 2. And you will see here that this time it took about 1.65 milliseconds. It was up there and then it disappeared pretty quick. But 1.65 milliseconds versus 600 something milliseconds when the setting was set, the threshold was set more to the left than to the right. And you're seeing here that it is your RX path is quite a bit shorter here as well. You've got the RX mainframe and identified the application, but then you've got these tildes here, or these forward slashes, axis here, specifiers, and these are acting as wildcards. And these wildcards are giving it the behavior of saying more of like, okay, well, we're fine. We're just looking for any descendants of the button for the control name button 2. And so therefore it was able to find it. And so if we highlight that, if we do a highlight on that button, there you go. It found this particular button through that path. So what was demonstrated here is, as you see under the Advanced tab here, we have this setting set all the way to robustness, which basically equals flexibility. But as a result, we took a hit on our speed, and instead of about 600 milliseconds, we're looking at 1.32 seconds, because we basically, that this is stating, hey, I'm not really concerned exactly where button 2 is. I'm going to find it, and I can move button 2 to a different tab. I can move it somewhere else, and it's going to go and search, and it will find that particular button. But as a result of not having that direct path, that increases the time. So now we've seen sort of two extremes. We've seen robustness. Let's go here and look at this. We've seen, the robustness set all the way to the right. We've seen speed. So this for flexibility, and then for the speed, way to the left. But, like most things in life, the best setting is probably somewhere in the middle for this quantile threshold. And generally, somewhere between 30 to 50% or 40 to 50% is probably ideal, more ideal. So let's go ahead and set that somewhere in the middle. Go ahead and apply. Okay. Okay, so now we're going to go ahead and track on button 1. And it's coming up here. It looks here that it found the element in 845 milliseconds versus I think it was like 1.67 seconds or something like that before. And when with it set to the robustness or the flexibility versus the speed. So the speed was around like 600, something like that. And if we look at the path editor, we will see here the path that we have the form here, the control name, and then right here we have it basically skipped over there, and you can see these axes with the question marks here, and I will explain that in a second about the wildcards and how they function. But Ranorex basically put this path in here and in here, and it's basically going to the tab page, so it's being a little bit more direct, saying where it needs to go, not as direct as when you have that set all the way to the left for speed on that little slide on the little slider. And down here you also have the control name button 1. Go to the browser results, you see button 1, and then you click up and it's going to the tab page. And if we click again here, we see that it's going to this basically box here, and then it goes to the entire application. So that's pretty much how that works. So speaking of wildcards, this is how this works within Ranorex, and we'll start here with the bottom one. Here you have the two axis slashes here that says for any descendant. So any UI element in any number of the descending tree levels below it. And then we have the one with the question mark, which is any optional. So this is any UI element that is exactly 0. So could be within this tree, within this level, or one tree level below. And then this one is with the asterisk. It means any UI element that is exactly one tree level below. In other words, not at the current tree level, but at one tree level below. Okay, to show sort of a practical example of some of the wildcards, let's take a look at this this RanorexPath here. And right now it says button 1, but we're going to go ahead and come up here and we're going to change that to button 2 and hit enter. And it found button 2 listed here. And we've got browsing results, button 2, and if you hover over it, you see that it is detecting that button 2 there. But there are other button 2s here. So let's say we wanted to look at some of the other ones, or to pull all of them up. We can go over here and let's look at the path editor again. And right now, of course, we're using the control name, but we could, there's all sorts of attributes that we could use. And so I'm going to change this to use the text one here and uncheck the control name. And if you expand on these, you can also see all of the other attributes that could be used in conjunction or in pair with this element. So right here we've got the button 2, and let's see if it can still find the button. We hit enter, and it shows button 2, and it's still finding the button 2. It's finding the text on here, button 2. But if we come up here and we put a / another axis right here, and put this wildcard here, and this is saying to find any in the tree structure, we go ahead and hit enter. And as you see now, it's finding the different buttons. In fact, can't hardly see it because of the screen, but if we come over here and we highlight the different buttons, it is finding all the buttons that are in this particular path. So, but let's say we aren't going to use this for all tree levels, but just for the one below it, we can go ahead and add the tilde / here, and or tilde, this axis, and then the asterisk, and then what we'll do is hit enter and see what it finds, and it finds 2 of them. And if we go and highlight these and hover over them, you can see that it found the button 2 for panel 1 and for panel 2. So we basically just stated just below. So let's put this wildcard in there a second time, and let's see what transpires. So we go over here, hit enter, and you see now it's finding it, finding 4 buttons. We'll move this over a little bit so we can hover over and see what it's seeing. And when you highlight it, now it's finding 1 level down again. So now we're sort of, with those 2 entries in there, in the RanorexPath, it's going basically 2 levels down and finding the button 2s for those items. And finally, if we put in here instead, let's go ahead and say, instead of that, we're going to take that out and use a question mark instead, and we'll hit enter to see what it finds. And it finds 3 buttons. Now it's looking at the current level, and it's looking at one tree level below. So if we go over here and see what it's finding now, you will see that it's finding the button at the top level, and then at the one right below it. And so we are finding those 2 buttons as well. And this is pretty much how the wildcards work. So now we're going to go over to another tab here. We're going over to the UI element test area. This is another little playground that is inside the Ranorex Studio demo application. You know, you have the capability of changing radio button group box. There's a list box here. There's a tree view, and there's a table here. And one of the things that we want to look at is here in the tree view, you know, we have like the Ranorex Studio Expert here, and what we will do is go ahead and track on that particular item, see what it brings up. And we see that it is generating here. Let's see if we can figure out there. It found the Ranorex Studio expert item, path editor, and it created a path here going down, and you can see that in the RanorexPath it already used a few of the wildcards that it generated itself to, for one, it is saying that of course it needs to be in, let's go back here, it's a pretty big control name, it's got to be in the mainframe or application, and then there's some basically here saying that look in some of the nested groups. It does need to be in the tab page, and you've got your RxTab UI elements, and going down in the test view tree, the different things that it can see to find the Ranorex Studio expert. And let's go to the browser results, and we can move this over here, and you can see here that it's looking for the tree view. You go up there, and there's two. You can see here it's got you have the frame that goes around excluding that scroll button, and then there's another tree level that goes higher that has the the scroll bar. Go up, and now it's looking at the entire page of this particular tab, and then of the different tabs there, and finally to the application itself. Now, in addition to tracking this Ranorex Studio expert, we can also go in here and we can track one of the sub-elements of that tree. So we're going to come in here and say like regular expressions, and of course it tracked that item, and of course it added it as another tree item, and identifying it by its accessible name. But we could also try to see the other siblings, and this is where we can talk a little bit about the access specifiers. So an access specifier, if we wanted to go ahead and pick up on these other siblings, we can go over here and we can put an access and put following sibling, and then we would say tree item. Let's see, actually I think I need another colon here. And then if you notice here, sorry, it's supposed to be 2 colons here, and then you will see here that you have actually the different code, that it's found all the siblings below it in this tree structure. And there are other syntax or access syntax that are listed on the Ranorex page. And let me see if I can quickly just show that to you. So to access these, to find the different options for the access specifiers, you can go to our support page, go to the Help Center, and then go down to the user guide, and then to the advanced, and look for the RanorexPath. And if you look at the syntax, it will discuss and give you information about the different options. You have a discussion about the access, attributes, and functions, and you pretty much have a lot of different examples that you can use. And in fact, we'll find down here the one that we just used, which was following sibling. But there are others here to help to pull up the different elements that you're seeking, so you can add those to your RanorexPath and to be able to pull those up. So now we're going to take a look at tracking elements inside a table. So let's go back over here. In fact, we'll hit the track button now, and we will look at the table, and it's showing your first name, last name, and all these different columns. We're going to go ahead and click on Thomas here, and we will see that it brings up Thomas here. Well, actually it brings up the accessible name, this is what Ranorex chose as the attribute, and it says accessible name equals first name row 3. If we look at that over here, we see, so that's indicating that that's the column plus the row number. So counting down, and if you go starting with 0, 0, 1, 2, 3, then you have Thomas in here. But the problem is this is, if this were a dynamic UI element, then tracking on this first name row 3 may not be adequate. So if we come over here and hit shuffle, now Thomas is actually at the top. But if we come in here and we refresh, let's go here searching. So now it's still finding it and tracking it, but it's now thinking that, let me move this over a little bit, but it's showing that Henry is now in that position. So it didn't track Thomas, it's just tracking the first name in the row 3 over, first name in row 3. So we probably need to find a better means to track this dynamic UI element of Thomas. So what we're going to do now is go ahead and instead of using the @accessible name, we're going to change this to use an attribute of text equals, and keeping it within the single quotes, we're going to say Thomas. And then we will hit enter. And see, and if you see it finds Thomas, but unfortunately what we're finding here is it's finding 2 Thomases. And that is because there is a Will Thomas for, Thomas in the last name. So we need to find another means to make this work for us. So now to narrow this down to what we're really looking for, we're going to use an operator at the end of this, which means to edit this Ranorex syntax, we're going to remove this closing bracket just for a second and use the operator of Thomas and then we're going to say @accessible name is equal to, or not equal to, we're going to say greater than first, and we're going to put the closing bracket and go ahead and hit enter, and you see here it did find what we were looking for, and it only found the first Thomas here. So now if we go in here and we shuffle this, come back here and we do a refresh, it still finds Thomas. But if you were looking instead for not, let's say you actually were looking for another column for Thomas Bach and not just the first name, then you could basically look at the different column levels or the column numbers. This would be 1, 2, 3, 4. So what we're looking for is column 4 to see Thomas's age, and what we'll do here is we'll add another operator to it, and we're going to put the axis axis and put cell in brackets number 4, and we'll hit enter, and it basically brings it up, age row 4, and it shows his age. And even if we go ahead and we shuffle this over here, if we refocus on this and refresh, and it will still find the age as well. So looking at our demo app here, we're going to go over to dynamic IDs here, and we'll talk about this dynamic IDs here for a moment. If you look right here, we've got this little image picture here But being dynamic, every time you click and uncheck it, it basically changes the current ID of that image. So this sort of can pose a problem. So let me show you. If we go over here and let's say we want to hit track, and we track this image, you'll see here that it captured the image here, and it's using the control name of this particular image. And so right now that is great. If we are trying to highlight it, it is seeing it. But if we go in here and the image changes, we come in here again and we refresh, and right now it is unable to find that image any longer because of, and we'd have to retrack it each time. So that would be the problem with this. It's constantly changing its name, so we have to figure out a way of what can we do to get around this issue. So this gets into the topic of path weights. Path weights are used, basically these attributes and they're given weights, and this is what Ranorex uses to decide on the construction of its path. So the higher the weight limit is, that's going to take precedence or priority in being one of the factors that Ranorex uses to determine the best attributes and to use for identifying the UI elements. Anything that of course is like less than 100 is going to be ignored. Right here you can see the control name would, in this instance, would have the most weight here at 150. The ranges can go up to 200. But if we want something to not be used as an attribute, then we can set that in our, for that particular element, we can establish the weight that we want to use in that, and we can set it low enough so that it's not really looked at. So over here we have this edit the attribute weight. So we're going to go ahead and take a look at that. And what we are going to do is we're going to add a rule, an unnamed rule. We'll call this the RX demo dynamic, and then we are going to look for the control. So we'll go down here to control where it says control, and we will say that we're looking at the control name, and currently it is 150. What we can do is just change this to like 99, and then this will not be used as the determining factor for creating the for creating this particular weight rule. So now if we track again and we click on this, you will see that it basically is not using the control name. It has changed the control type name to picture box. And so now if we go ahead and go in here and we change this to something else and the name changes, we can come in here and we can still refresh, and it's still able to find it each time. And this concludes today's webinar. Thank you for your time. I hope that you learned something from this webinar, and if you do have questions, feel free to reach out to us, and we will be happy to answer them. In addition, do not forget, if you go to our website, there is a wealth of information in our user guide, and there's lots of information and also in regards to what we discussed today. And thank you again.
So again, thank you for joining our webinar today. If you've not had a chance to try Ranorex, if you're not yet a user, please feel free to try our download of our free trial. You can go to ranorex.com. You can find that there. Looks like we might have a little extra time, so let's move on to the Q&A session.
Okay, we did receive a few questions here, so I'm going to take a look at some of these questions. One of the questions was whether or not Ranorex, works well with dynamically generated IDs. So dynamic IDs is always, can be a challenge for any sort of UI tracking tool. But Ranorex does quite well, and as shown in the webinar, you have to look for certain elements, and probably, for example, you might not be able to use the control set name. You might have to use you might have to adjust the weights or something like that, make a rule to adjust the weights and maybe add some conditions for it to be able to find those dynamic IDs. So Ranorex does, yes, it does support, it certainly supports dynamic IDs, as we've shown here. And those are things that you would continue to, if you do run into tracking issues or something like that, you can open a case number with the support desk, and they will be happy to try to help you resolve that if you do come across something like that. One of the things was, which XPath works faster, one with a question mark or one with, the two axis symbols in it? Well, you've got one basically that's looking at the current level and the one below it, basically, when you're using that question mark symbol, and the other one is using looking through everything. So of course, the one that has to look through everything and all the directory tree structures is going to be probably a little slower compared to just looking at what you necessarily need to. And let me see here the other questions that came in. Let's see. Many things from webinar. How can I find dynamic elements? Okay. And of course, when you're dealing with, one of the questions was about, menus and things like that, hovering menus, and we do have the hotkeys that are used for tracking elements, and sometimes you might have to use, the move hotkey to be able to highlight, let's say, a flyover menu or something like that that's only appearing for a short time, to basically find and track that element so that you can, get the correct Ranorex path for it to add to your test case. So that is something that you might want to explore. If you go into our user guide, there's discussion on the mobile hotkeys, or I'm sorry, not the mobile hotkeys, but the hotkeys in the recording when you're doing the recording, and it will show those different things to help you find those particular elements. Let's see what else we have here. One is on a mobile web page in Safari, the spy can recognize only a few elements. And do you have a hint for mobile testing? Well, for one, I mean, the standard browsers in Safari, especially on the mobile devices, you really should use the RX browser, the RX browser that you can install, and use that for tracking your elements. That's the best method. It's still going to, the one thing that Ranorex does is that it focuses on the DOM and not necessarily on any browser specific. But as you know, for instrumenting, when you're doing browser testing, for example, on the desktop, you've got to have those appropriate extensions in order for it, except for IE, you've got to have all these extensions to be able to track the elements. And on the Android devices and on the iOS devices, you really need to use the RX browser for finding the elements on your page and being able to add those to your repository to build the mobile test. And let me see. On the mobile web page, let me see, how can we find the dynamic elements? Let's see, and someone was again saying, in my app, I often get the /? in the path, and I was told to remove them. Probably not to remove them. They're put there to try to find a better path. I mean, as long as it's finding the correct path, and like I said too, with the dynamic slider, you can say exactly, you can remove it to robustness so that you're probably not having a lot of these wildcards that are in use, and it's finding that more direct path. Or if it's dynamic, it's moving around a lot, then if that quantile setting is set to that, then it's going to be more flexible. But you will, flexible in the sense that if the object moves around or things like that, it can still be found. But the problem with that is, of course, it will increase the delay in running the test slightly, and depending on how long your test is, then that delay might be more significant on that one. So this looks like about it. So this pretty much concludes the webinar. So if you guys do have any questions or follow-up questions, please send them to the email address. I think it was evaluations@ranorex.com, and we will be happy to answer your questions.
So thanks for attending. That's all the time we have for today. Be on the lookout for the follow-up email with the link to the recording. And if you have any additional questions, please feel free to email our team at evaluation@ranorex.com, and have a great day.